Hey guys, and it's been a while since I've made another video, so I decided to just make one on a PWM circuit that you're seeing right now. I'm doing a voiceover because I struggle to speak too much in the actual recording, so I'm just gonna go over the circuit for you guys. So this is a potentiometer, or a trimmer, and another one on the other side, which this is used to adjust the minimum and maximum duty cycle of the PWM signal. What you are currently seeing is a triangle wave that is being generated by the 555 timer on pin 2. And I'm going to try to explain the theory to the best of my ability, but overall it's quite simple how the PWM circuit actually works. So let's get started with the 555 timer. So on screen here, you see a 555 timer circuit which is used to make a triangle wave at 31 kilohertz powered with 5 volts, and there's a 10 microfarad decoupling capacitor so the waveform doesn't look like crap. And there's a 15 kilo ohm resistor which is used to set the frequency along with the other capacitors. But I don't understand much about a 555 timer, but this is basically what it does. This triangle wave is fed into a comparator. Now in order to understand how this PWM conversion works, we need to know how a comparator works. So basically a comparator works by comparing two voltages, and depending on what the voltage is on rather V plus or V minus will determine if it outputs. So basically, if V plus is higher than V minus, then the output will be high, which is 1. But if V plus is under V minus, then the output will be low, which is 0. Basically, what's happening here is we're feeding the triangle wave into the in plus of the comparator, and on V minus we'll be putting in a voltage reference, which is basically controlled by a potentiometer, and that's how the PWM's duty cycle is controlled. And as mentioned in the beginning of the video, these two trimmers, the 1K trimmers that you can see here, are just there to set the minimum and maximum duty cycle. Now as I change the voltage that is going into V minus, the duty cycle changes. And I put the triangle wave there for a reason, along with the changing voltage. Alright, so what I have pulled up here is Desmos, because my editing sucks, and basically what you're seeing here is the triangle wave. The black bar here is basically the PWM signal, and the voltage that is on V minus is this dashed line here. And as I increase the duty cycle, you see how the dashed line is going down? Since you guys already know a little bit about comparators since I just showed you, this would make sense why it's doing that. Alright, so here's the PWM which set the lowest duty cycle. And there. Yeah, the frequency may drift around like a tiny bit, but it's not as bad as the 555 timer if you think about it. Really unstable. That's on the 555 side right now. Now let's just do a bit of a load test. Alright, so you may notice it's a little bit brighter now because I have an LED on, which is powered with 3 volts or a 3.7 volt battery. This is on the lowest duty cycle, and as the duty cycle gets higher, it gets much brighter. And this is very bright right now. It's not even at 100%, I just need to calibrate it again. There we go, now that's 100. See that? And then, there. Obviously when it's under a load, you might see a little bit of obvious ringing right here, I think. Yeah. But see, it works quite well. Alright, so we got a fan attached to it, and I power it with my power supply exactly set to 12 volts. I'm going to move it in case it falls. I want you guys to pay attention to the PWM, as well as the fan speed. Alright, this is minimum, and since it's an inductive load, ring might get quite bad, or some spikes might get quite bad at the MOSFET's drain, but I'll fix that later, I guess. Anyways, here we go. I think you should be able to hear a clear difference in audio between how fast the fan's going. Minimum speed, maximum speed. Do a very slow sweep now. Overall, I'd say the circuit is quite useful, because it has, well, 2 inputs. This ground is the same one, so this is for the 9-volt battery, so it powers the PWM side, and this is for the load, so it powers the load side. Whereas last time it was just a mess. Actually, I'm going to show you my older design. Let me get it real quick. God damn it, this terrible design, man. Like, look at this. Mess. if I look at this back, it's kind of the same. I put a diode in case I connect the battery backwards somehow, depending on what I'm using. So this basically toggles it on or off. Same concept here, but the main difference is it has an output which, well, it outputs from VCC or this adjustable voltage regulator. I had to put the VCC mode because, well, let's just say the output, it will not go to VCC if it's adjustable. Yeah, that's how annoying it is. It just won't go to VCC if it's adjustable. Now let me just voice over this part real quick because I made a mistake. But what I was trying to say is this LM317T I'm using, which is an adjustable voltage regulator, I put them in parallel so they can handle about 3 amps in total and not 1.5. But it turns out they were terrible, and basically a voltage drop occurred the moment I put it under a load. And that's why I dislike the circuit. And also, I accidentally said LM393 in the video. I don't know why. Hey guys, and I decided initially that I wanted to make this video in one go, but then I didn't even end up doing that for some reason, because I don't know. I just wanted to do some of the editing and then I got lazy, so I just decided to go ahead and draw. And then eventually I found some solutions that'll make the video a little bit easier, like the Desmos part. Yeah, because I wanted to edit something, but since I'm not a professional editor, I just decided to go ahead and use Desmos to make my life a little bit easier. And I kind of just came across that today at school for some reason, because I didn't even think to use that for 1 second, but whatever, it happens, and it happens all the time. Anyways, as usual, the schematics will be posted along with the part list in my community tab, and you guys can make the circuit for yourself if you want. I'll still be uploading, but I'm not going to be uploading much at all. Or maybe I'll just be uploading short videos. Not short, but short videos. Anyways, I'm just going to go now.